It's another time with BakoMaths, and to this lesson we'll be looking at binary operation involving sets. And if you have not subscribed to this channel, kindly spend a moment and subscribe so that when a new video is being published, you are going to be the first person to be notified. Now let's get started. Example 1, and it is written here that a binary operation star is defined on the set of real numbers R by x star y, which is equal to x squared minus y squared plus xy. Evaluate square root of 3 star square root of 2. So just like the topic said, this example of binary operation involving sets. So you are going to solve it respectively. Now, given the operation or rule as x star y, which is equal to x squared minus y squared plus xy, and we are going to use this rule to find square root of 3 star square root of 2. So it means that wherever we see x in the rule, we are going to substitute square root of 3, and that of wherever we see y, we are going to substitute square root of 2. So having known that, we are going to do that quick substitution. So it means that for x squared, there we are going to have square root of 3 squared, and for y squared we are going to have square root of 2 squared. Now plus xy, that means square root of 3 multiplied by square root of 2. Now here we are going to simplify, and we can see that this square root sign is going to take away the square, and then we are left with 3. So you write 3 here, and the same thing applies to square root of 2. So the square cancels the square root sign, and we are left with 2. So plus, when we multiply this square root, then we are going to have a square root of 6. Now we can see that 3 minus 2 gives us 1, so that is 1 plus square root of 6, and we can rewrite this as square root of 6 plus 1. So that is it. That is for square root of 3 star square root of 2. And this is how we can solve examples related to binary operation that involve sets. Now, having known this, let's go to the next example for today's video. So that is example 2, and example 2 says that a binary operation star is defined on the set of real numbers by p star q, which is equal to p squared plus q squared minus 2pq, where p, q belongs to all real numbers. Evaluate square root of 3 star 1 out of square root of 12. So here the general rule is p star q, which is equal to p squared plus q squared minus 2pq, and here we have square root of 3 star 1 out of square root of 12, which means that wherever we see square root of 3, then we are going to wherever we see p, we are going to substitute square root of 3 there, and that of q, we are going to substitute 1 out of square root of 12. So respectively, then we have here square root of 3 squared plus 1 out of square root of 12 squared minus 2 multiplied by square root of 3 multiplied by 1 out of square root of 12. Now this we are going to simplify. So it means that we can see that the square cancels the square root, so we are left with 3, and we can rewrite it well. So that the square cancels square, we are left with 3, and 1 squared is 1, and square root of 12 means that the square is going to cancel the square root, so we are left with plus 1 out of square root of 1 out of 12 exactly, minus here we maintain 2 and that of square root of 3, and we can see that for square root of 12 it's not in basic form, so you have to reduce it to basic form by considering the factors of 12 that we are going to select the highest or the biggest perfect square, and a number we multiply by the perfect square, we get 12, and that is basically square root of 3 and square root of 4. So these two numbers that when we multiply, we are going to get square root of 12, and they are coming from the factors of 12. So having known this, we continue, and here we are going to have is equal to 3 plus 1. So you can rewrite it well. That is equal to 3 plus 1 out of 12. And then we have minus. So here we can see that this square root of 3 can take away the square root of 3 here, and we are left with minus 2 multiplied by 1 out of. So we are left with square root of 4 here. So square root of 4 here we know to be 2. So we have our 2 here. Now we continue, and we can see that when we sum 3 and 1 out of 12, we are going to get 37 out of 12. So that is 37 out of 12. I think you have to write it so neat. So that becomes 37 out of 12 minus. So you can also see that this 2 is going to take away that 2, and we are left with 1. So when we subtract 1 from 37 out of 2, our final answer becomes 25 out of 12. And this becomes the solution to this question. So it means that for square root of 3 star 1 out of square root of 12, we have our answer to be 25 out of 12 using the rule given in the question. Now, having known this, let's try the next example for today's video. So that happens to be example 3, and example 3 says that a binary operation, let's call this dot, is defined on the set of real numbers by a dot b is equal to a plus 2 divided by a plus b, such that a is not equal to negative b. Find 3 dot square root of 2, leaving your answer in the form p plus r square root of 2, where p and r are rational numbers. So it means you have to simplify 3 dot square root of 2 using the operation given to us or the rule given to us, and at the end we have to simplify or write our answer in the form p plus r square root of 2. So basically we have our rule as a dot b, which is equal to a plus 2 divided by a plus b. So here we are looking for 3 dot square root of 2. So by direct substitution, we are going to have 3 plus 2 divided by 3 plus square root of 2. So here we can see that there is Z at the denominator, and mathematics, when there is something like that happens, when there is Z at the denominator, we have to rationalize by finding a conjugate as well, so that the denominator becomes a real number but not a complex number. Or sorry, you have to simplify so that the denominator becomes a real number but not a Z. So it means that by rationalizing and by finding the conjugate, we are going to have here as times 3 minus square root of 2 divided by 3 minus square root of 2. So it means that we are changing the sign at the denominator and multiplying it by both the numerator and the denominator of the fraction. So here we have 3 dot square root of 2, which is equal to, so what we can do is that this 3 is going to multiply 3 minus square root of 2. So 3 multiplied by 3 minus square root of 2. And we have here plus 2 multiplied by 3 minus square root of 2, all divided by, so we come to this one, the denominator. Means that 3 is going to take 3 minus square root of 2, and then plus square root of 2 also takes 3 minus square root of 2. So once that is done, then means our 3 dot square root of 2 now is equal to, so we multiply 3 times 3 gives us 9 minus, so here we have 3 square root of 2, and then here we have plus 6 followed by 2 square root of 2. Good. Now the next one, we are going to divide that and we are going to simplify the denominator. So 3 times 3 here gives us 9 minus, so 3 square root of 2, and we have here as plus 3 square root of 2 minus, so square root of 2 times square root of 2 gives us 2. That is from the properties of sets. So if you have not watched the video on that, kindly watch it. Now here we are going to simplify, and means 3 dot square root of 2 now is equal to, now we can see like sets here, which means you have to group them and simplify. So we group the like sets, that is minus 3 square root of 2 minus 2 square root of 2, and we have here plus 9 and then plus 6, all divided by, so at the denominator we can see that there is negative 3 square root of 2 and there is positive 3 square root of 2. So that goes away and we are left with 9 minus 2. Now at this point we have to further break it down, and we have 3 dot square root of 2 giving us, so here we are going to have, for the like sets, because they have the same irrational part, that is square root of 2, we have to add the rational part and maintain one of the irrational parts. So we mean minus 3 minus 2 gives us minus 5, and we bring one of the irrational part, that is square root of 2. So now we know 9 plus 6 gives us plus 15, and 9 minus 2 gives us 7. So just like the question said, it said we should simplify our answer in the form p plus r square root of 2. So it means that we have to rearrange our solutions in that way. So for 3 dot square root of 2, then we are going to have as 15 out of 7, then minus 5 out of 7 square root of 2. So that is that. So it means that where from the question says we should represent it as p plus r square root of 2. So where p now is equal to, that is 15 out of 7, and you can see that our r value now is equal to minus 5 out of 7. But then we know that square root of 2 is the same thing as square root of 2, so we maintain that one. So basically that's how we can find the value of 3 dot square root of 2 by the given operation, where p is equal to 15 out of 7 and r is equal to negative 5 out of 7. So basically that's how we solve the question, and we are going to the last set of examples for today's video. Now example 4. So if you have not subscribed to BakoMaths, kindly spend a moment and subscribe, and you can also try this question. So you can pause the video and try as we also solve along. So here it says the binary operation delta is defined on the set of real numbers r by p delta q is equal to p out of q plus q out of p. Evaluate square root of x plus 1 delta square root of x minus 1. So here the given rule is p delta q, which is equal to p out of q plus q out of p, and we want to find square root of x plus 1 delta, that is square root of x minus 1. So we are just going to do substitution. So it implies that here our p is square root of x plus 1 divided by q square root of x minus 1, and then we have here as plus q, we know here to be square root of x minus 1, and here we have square root of x plus 1. So here what we can do is that we have to simplify. So we can simplify by taking into consideration the LCM of this fraction. So you can see that the LCM here is square root of x minus 1, and we have here as square root of x plus 1. So now the square root of x minus 1 goes into square root of x minus 1. We are left with square root of x plus 1. So that is square root of x plus 1. And that one multiplies the numerator, square root of x also plus 1. And the same way we have our plus here. So this square root of x plus 1 goes into x plus 1. We are left with the other one, that is square root of x minus 1. So let's redo the square root. So square root of x minus 1, and that multiplies the numerator as square root of x minus 1. Okay, so that is x minus 1, x minus 1. Good. So here we continue, and we can see that we can multiply. So square root of x multiplies square root of x, that gives us x, and square root of x multiplies 1, we have plus square root of x. So here we can see that 1 multiplies square root of x, we have plus square root of x, and 1 multiplies 1, we have plus 1. In the same way, when we come here, square root of x multiplies square root of x, that gives us x, and square root of x multiplies negative 1, that gives us negative square root of x. And when we come here, minus 1 multiplies square root of x, that gives us minus square root of x, and minus 1 times minus 1 gives us plus 1, all divided by, we also expand out of the denominator. So square root of x multiplies square root of x, that gives us x, and then square root of x multiplies 1, that gives us plus square root of x. And when we come here, we can see that minus 1 multiplies square root of x, that gives us minus square root of x, and minus 1 multiplies positive 1, that gives us minus 1. So it means that we can cancel some of the terms here. So here we can see that there is negative square root of x is going to take away this positive square root of x. This negative square root of x takes away the positive square root of x, and the only terms left here are x here, x there, we have 1, we have 1 there. So we are going to sum them. So it implies that our solution now becomes, so x plus x gives us 2x, and then 1 plus 1 gives us plus 2, divided by, in the same way, this takes away that, and we are left with x minus 1. So we can also further break this down, and we are going to have here as, so we factorize 2 out, and we are left with x plus 1, and also we are left with x minus 1. And this becomes the solution to our question as square root of x plus 1 delta square root of x minus 1. So basically, this ends today's video and the set of examples for binary operation involving sets. And so thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is BakoMaths, thinking beyond infinity.